Let's do a quick review of ease and natural logs, as well as product rule, quotient rule, and chain rule, so that we can put those together here in Unit 5. So if you remember, a log and an exponential function, those are inverses of each other. So like a square and a square root, they are opposite functions, they are inverse functions. And so the log form of log base 3 of 81 equals 4 means the same thing as 3 to the 4th equals 81, one in logarithmic form, one in exponential form. And then the common log is base 10. That's an error there. And the natural log is base e, and this is the one that we are going to use pretty much all the time. So we do a lot with e's and natural logs, which are inverse functions of each other. So if we look at the properties of natural logarithms, the natural log of e is opposite function. So it's natural log, then it's e. They are undoing each other, so that is just 1. The natural log of 1 is like saying, if that's base e, then e to what power is 1, and that is 0. So the natural log of 1 is 0. And then e to the natural log of x, again, we're doing and undoing, and so that is just x. And then natural log of e to the x, also just x. We can also expand and condense, and it's again similar to exponential rules, such as x to the 3rd times x to the 2nd is x to the 5th. When you're multiplying, you add the exponents. Also, so when you're multiplying within a log, you can split it up by adding. So natural log of a times b can be written as the natural log of a plus the natural log of b. Natural log of a divided by b can be written as natural log of a minus natural log of b. And then if we have this power here, a to the n, we can actually move that out front. So this can be written as n times the natural log of a. So a couple problems to practice expanding here. Natural log of 5 divided by 6x squared would be natural log of 5 minus natural log of 6x squared, if we're going to do this in steps, which is natural log of 5, make my pen smaller, natural log of 5 minus parentheses natural log of 6 times natural log of x squared. And we can expand more by moving that 2 on the x squared out front. So this is natural log of 5, and we can distribute the negative, so minus natural log of 6 minus 2 natural log of x. Let's do the same thing on number 2. We're actually going to rewrite this square root as 1/2 power, which allows us to move that in front. So this is 1/2 out front, natural log of 3x plus 2, and that cannot be simplified any further. So that is the answer there. That does not go any further because there is not multiplication or division inside. So if we want to condense, we just go the opposite direction. We put those numbers out front as powers. So natural log of x to the 3rd plus natural log of y to the 2nd. And since we're adding 2 natural logs, we can combine them with multiplication. So this simplifies to be natural log of x cubed times y squared. And that is the condensed version of that. Same thing on number 4. We take our number out front and it becomes a power. And so we have natural log of 16 to the negative 1/4 power minus natural log of x to the 3rd power. And we can actually simplify 16 to the negative 1/4 power, which is 1 over 16 to the 1/4, which is the 4th root of 16 on the bottom there, so 1/2. So this is natural log of 1/2 minus natural log of x to the 3rd. And when we are subtracting 2 logs, we can combine them together, condense them together with division. So natural log of 1/2 divided by x cubed, which we can write as natural log of 1/2x cubed. So the purpose of expanding and condensing is so that we can do different things with that problem depending what it is that we want to do. So let's do some simplifying. If you remember, natural log of e to the natural log of x right here is x because they are doing and undoing. So e to the natural log of x plus 2 is x plus 2. The reverse of that is also true. Natural log of e to the x plus 2 is just x plus 2. Number 3 is similar, but we need to rewrite it first. So this is natural log of e to the negative 5, and then this looks just like number 2, and the answer is just negative 5. Same thing with number 4. We're going to write this as natural log of e to the negative cube root, so 1/3, negative 1/3, which is just then negative 1/3. The e's and the natural logs cancel each other out, but they have to be right next to each other. So number 5, again, we want the e's and the natural log to cancel out, but we can't do that unless the e and the natural log are the direct connecting functions. So we need to rewrite this as e to the natural log of 6 to the negative 2 using our condensing rule there. And then the e and the natural log undo each other, cancel each other out. So that's 6 to the negative 2 or 1/36. Similar with number 6, we can put that 1/2 power there. So e to the natural log of 16 to the 1/2. The e and the natural log cancel each other out. 16 to the 1/2 then is 4. On number 7, again, we want the e and the natural log to be connected, and so we will need to rewrite this. E to the natural log of 3 squared minus natural log of 2. Still not totally connected, so we need to condense the top to be e to the natural log of, when we're subtracting logs, we can combine them into division, so 9 divided by 2. Now the e and the natural log are right by each other and therefore cancel each other out to be 9/2. Number 8, we need to move this 3 to the power. So we have e to the natural log of 5 to the 3rd plus 4. And since that plus 4 is not inside the natural log, those do not just cancel. But what we can do is use this rule here, x to the 3rd times x to the 2nd is x to the 5th. I kind of do that backwards. So if we're adding 2 powers on e, we can actually split that into e natural log of 5 to the 3rd times e to the 4th. So we're used to doing that the other direction. Like we have here, x to the 3rd times x to the 2nd, we add the exponents. Well, we can also split it up if we are adding the exponents, and we can split that into 2 different base e's. And then we have e to the natural log of 5 to the 3rd, which is 125, e to the 4th. Okay, let's do some solving. So again, since these are opposite functions, you just need to isolate the e or the natural log, isolate whichever one it is that you're solving for, and then do the opposite function to it. So on number 1, we have the natural log by itself. And so to undo a natural log, we exponentiate both sides. So we're going to do e to the natural log of x plus 4 and e to the 10th power. So we are doing e to the natural log of x plus 4 equals e to the 10th power. Exponentiate both sides because e to the natural log cancels out, and we get x plus 4 equals e to the 10th. And then we can solve for x by subtracting 4. So x equals e to the 10th minus 4. Number 2, we have e to the 5x. We need to undo the e, and the way to undo that is to log both sides, and we need to log base e, which is natural log. So natural log of e to the 5x equals natural log of 3. Natural log and e cancel each other out, so 5x equals natural log of 3 divide by 5. X is natural log of 3 divided by 5. Here's another one with multiple logs in it. This is where your condensing is going to come in handy because condensing puts everything into a single log, and that's what we need to be able to exponentiate both sides. So we are going to move natural log of 5 to the left so that we have natural log of x plus 2 plus natural log of 5 equals 3. And then we can condense them into a single log of natural log of 5 times x plus 2, or 5x plus 10. Now we have a single natural log by itself, and we can exponentiate both sides. So we e both sides, we exponentiate both sides. So on the left, we have 5x plus 10, and on the right, we have e to the third. Then we subtract 10, and we divide by 5. So we subtract 10 from both sides, we get 5x equals e to the third minus 10, divide by 5, and x equals e to the third minus 10 divided by 5. So a note here, Delta Math will not accept e's and natural logs together, so you may have to do some sort of simplifying, expand, and condense like we did here on these problems. If any of your answers look like this after solving, then you need to do some simplifying so that e's and natural logs are not together. So that's our review of e's and natural logs. Now we're going to review product rule, quotient rule, chain rule, and equation of a tangent line so that we can start applying those all together. So if we have g of x is the square root of x times cosine x, then we want to take the derivative. We need to recognize that we are multiplying these two things, and therefore we do the product rule. So g prime of x is going to be the derivative of the first, keep the second, and then switch that. So we need to think about x, square root of x as x to the 1/2. So if we take the derivative of the first, that's 1/2 x to the negative 1/2. Keep the second one, so times cosine x. That's derivative of the first, keep the second. Plus, do the reverse. So keep the x to the 1/2 times the derivative of cosine is negative sine of x. And we don't really need to simplify unless we have a reason to, but for practice, the simplified version would probably look something like 1/2 root x cosine x, or cosine x on top there, minus square root x sine x. Number 2 is quotient rule. We have one function divided by another function, and so to take the derivative of that, we need to do low d high, so low x squared. D high, the derivative of tangent is secant squared x. Low d high minus high d low. So high is tangent x. D low is the derivative of the bottom, 2x, over low low, which is x squared, squared. And then again, if we want to simplify this, I'm going to rewrite it first. So x squared secant squared x minus 2x tangent x over x to the 4th. So we have two terms on top, one on the bottom, and they all have an x in it. And so we can factor out an x on the top and then cancel, or divide out an x, or just take an x out of every term. However you think about that is fine. So g prime of x simplified is x secant squared x minus 2 tangent x divided by x to the 3rd. Number 3, this is chain rule. So we have function inside of another function inside of another function. So what do we have here? We actually have 3x inside of sine, which is inside of a squared. And so to do chain rule, we do everything in that order, or that reverse order. So power rule first. Remember, this is sine of 3x all squared is what that squared there means. So power rule first. So just the power, 2 out front, keep the power of 1, keeping the inside. So sine of 3x times, we did the squared, and so now we're working our way inside. So now we have sine of 3x. The derivative of sine is cosine. So we take the derivative of sine, which is cosine. We keep the inside, 3x, times the derivative of the inside, which is 3. And if we want to rewrite this, this is all multiplication, so I can write it in any order I want, which will be 6 sine of 3x times cosine of 3x. And then last, we have the function, and we want the equation of a tangent line. So a tangent line is an equation of a line. We need a point and a slope. So if we need a point, we want the point to something. So we are looking for f of 2, which is going to be 2 times 2 to the third minus 2 plus 3. So 2 to the third is 8 times 2 is 16 minus 2 plus 3. So 16 minus 2 is 14 plus 3 is 17. So our point is 217. Our slope is f prime of 2. It's the slope at 2. So first we need f prime of x, which is power rule, 6x squared minus 1. So f prime of 2 is 6 times 2 squared minus 1, which is 6 times 4, which is 24 minus 1, which is 23. So our slope is 23. Our point is 2 comma 17. So our equation of the line using point slope is y minus 17 equals 23 times x minus 2. And you can leave it like that unless you have some reason or some instructions to write it in a different form. Okay, so quick review of all of that. We want to make sure we're really good at these so that we can dive into the rest of Unit 5. Have a great day.